Hello, in this video I'm going to introduce you to discrete random variables and also probability distributions. So I'm going to start off with what a discrete random variable is, and then we'll look at a probability distribution. I'll timestamp each part of the video below so you can just skip through to whichever part you want to see, and if this video is useful, please do like and subscribe. Before we actually look at a probability distribution, we need to be familiar with something called a random variable. Now this is just a variable that's value depends on chance, and we usually denote it with a capital X, like this. Now we're specifically interested in this video in discrete random variables, and what makes it discrete is that the outcomes we get can be listed. So for example, we could look at flipping a coin and getting heads or tails, or rolling a dice and getting a value from 1 to 6. Okay, whereas a continuous random variable would be perhaps people's heights or people's weights, things like that that don't take specific values, things that could be really anything at all. So that's what our random variable is, okay, and we can also introduce a lowercase x like this, and this is the value that our random variable can take. So for example, let's say our capital X, our random variable, is the score we get when we roll a 6-sided dice. Score when rolling a 6-sided dice. Okay. Well then our lowercase x could take a value from 1, 2, 3, 4, 5 and 6. Okay. And the notation we use to describe these probabilities is like so. We say the probability that our discrete random variable x would be, say, equal to 1 would be, well, what's the probability I roll a fair 6-sided dice and get a 1? Well, it's 1 out of 6. What's the probability I roll my first 6-sided dice and get a 2? Well, that's also 1 out of 6. So that's how this notation is going to work. So now we know what our random variables are, okay, we can now look at a probability distribution. And the way we're going to do this is with an example. So you can see here we have 2 fair 5-sided dice are rolled and their scores are summed together. Now the way I'm going to find all the possible outcomes is using this sample space here, which you're probably familiar with from GCSE. So I've got 1 plus 1 is 2, 1 plus 2 is 3 and so on, so I'll fill out this grid. So you can see I've now completed my sample space and I now know all of the different possible outcomes I can get when I roll 2 fair 5-sided dice and sum their scores together. So we could say what's the probability that my random variable, and in this case my random variable is going to be rolling 2 fair 5-sided dice and adding their score. So what's the probability my random variable is equal to, say, 2? Well, there's only 1 2, let me highlight it, there's only 1 2 out of a total of 25 different outcomes, so it's just 1 out of 25. Okay, so we could take all of the different outcomes and represent them in a table with their probabilities, and this would be what we call our probability distribution. So let me draw up a table and then we can complete it. Okay, so you can see here I've drawn out my table that is going to be my probability distribution, and I have here x, so the value that my random variable can take, so these are the outcomes that I've found from my sample space, and then below it I have the probability that my random variable is equal to that outcome. So for this box here, what is the probability that my random variable x, which is rolling 2 5-sided die and adding their scores together, the outcome is 2, well, like we looked at earlier, there is 1 out of 25, so it's 1 out of 25. What's the probability I roll my 2 dice and get a 3? Well, that's 2 out of 25, and so on. So I'm now going to complete this probability distribution. So I've now completed this probability distribution, and one thing you may notice is that if we add up the probabilities of all of our different outcomes, they sum to 1, and this is always true. So we can say the sum of all of the different probabilities in our probability distribution will always be equal to 1. And we can write this in a more mathsy way. So we can say if we were to sum, so this capital sigma just means to sum, to add everything together. Okay, the probability that our random variable x is equal to a value of x for all of the values of x's we have. So when x is 1, 2, 3, up to however many different values x can take, if we add them all together, we get 1. And you can test that. If you sum all of these together, we get 1. And that's pretty much it for this video, so hopefully it was useful. If it was, please do like and subscribe, and go over to my channel where I have loads of other maths tutorials. Thanks for watching.